This is a basic overview of the IR SupIRBuck Design Center. I'm actually going to access this tool from the Aero Electronics homepage. Select Electronic Components. There's an Online Design Solutions link. That's what we want. This brings us to Transm's Design Web. Here you can access all of Transm's online tools. I'm going to select Companies, International Rectifier, and my power. This should bring us into the SupIRBuck tool. The first step is for the user to log in. If they do not have an account, they will need to register and provide the necessary information. Username is usually an email address. Password. And select Login. This brings us to the Design Inputs and Part Selection page. Here the user will provide the design parameters: input voltage, output current, and switching frequency. These design inputs will be the filter criteria for the available buck converters. The user also has the ability to search for parts by protection features and functionality features. For instance, if I know that I want an integrated 12-volt bias LDO, I select that feature, select a part again. As you can see, the number of parts available got smaller. I'm going to go ahead and choose the IR3897. The user has now been brought to the design schematic. From here they have the ability to run simulations such as AC analysis, steady state analysis, and transient. They can view results, edit component values, and also configure the analysis settings. I'm going to go ahead and run the steady state analysis. Usually it runs pretty quick. Keep in mind this schematic is fully interactive. The user can edit these components, then re-simulate, and their changes will take effect in the simulation results. Once the simulation is finished, it automatically takes me to the Waveforms tab. Here the user can click on the waveform graph, which will open the WebScope waveform viewer. Within the waveform viewer, there are usually multiple waveform groups, each containing numerous signals, such as input, output, IC, and here we have all signals. Here I have full zoom capability. For example, if I want to zoom in, measure my switching frequency, I can adjust my measurement markers. And select the 1/T measurement function. And this circuit is switching at almost 600 kilohertz, as it was designed. I'm going to go ahead and go back to the schematic. Suppose I want to maybe adjust my load. Instead of stepping from 1 to 2 amps, I want to step from 0.5 to 1 amps. Select OK. And maybe I want to adjust my transient runtime. It's defaulted at 200 microseconds. I'm going to go ahead and just run it for 100 microseconds. Save. Run the transient analysis. And here are my results. Look at my load current. As you can see, it's stepping from 0.5 to 1 amp and only ran for 100 microseconds. Another feature of the IR tool is the Losses tab. Power loss tab gives calculated values for some of the critical power loss components, such as input and output capacitors, inductors, and main IC control and internal FETs. Another option for the user is the Redesign tab. Here, the user has the ability to design using more advanced parameters such as output voltage ripple or inductor ripple current. For instance, if I want to change my inductor ripple current to maybe 10%, select Design. As you can see, I get a warning saying that I will overwrite my previous design. Okay. Now, using my new inductor current ripple of 10%, I should have gotten a different inductor value. Next step in the IR design tool is the PCB design. Here I can view the current components that would be available on the demo board. I also have the option to move my components around, and also the ability to place new components. If I want to add a new component, give it a name, define its size, and also its nominal power. Place my component. The user also has the ability to define their board. For example, if I wanted to add another layer, simply choose the number of layers and provide the material information. .07 millimeters, I believe, is 2-ounce copper. I want 90% coverage. Once I'm done with my PCB design, I can continue on to do the thermal analysis. Here I have the option to set the air temperature, air speed, and air direction. As you can see, the components that are highlighted have a power loss associated with them. This is my test component that I added. Once I want the thermal settings, once I have the thermal settings set, I can run the analysis. When the simulation is finished, I can view my results, both the top and bottom sides of the board, along with the calculated temperatures of each component. Moving on to the Summary tab. This consists of an overview of each of the design steps I've covered so far. The user can see the design requirements, schematic image, bill of materials, electrical simulation results, board definition, efficiency plot, power loss calculations, and thermal analysis results. From the Summary tab, the user also has the option to download a PDF version of the summary. The last step I'm going to do is save my design. If you look in the upper left-hand corner, you'll see some menus here. This is actually our design manager. At any point in the tool, I can save my current status using the design manager. Simply select Save and give the design name. I also have the option to share my design with other users. I can send an invite to a specific user by selecting the Share button and providing an email, as well as assigning read or write privileges. The user that you share with will be required to create an account in the IR SupIRBuck tool if he or she is not already a registered user. The last topic I want to bring up is the feedback button. There should be a feedback button located in every one of Transim's tools. We would love to hear from you on how to improve these tools. Please use the feedback button and let us know your thoughts. Thank you.